All right, let's dive right in. Today, we're going to put all the speculation aside and look straight at the data on unidentified anomalous phenomena, or UAPs. So how do we get this conversation out of the realm of grainy photos and into hard science? Well, it starts with a checklist. Let's get into it.
You know, for the longest time, the whole conversation around this topic was just a process of elimination. If you could prove it wasn't a plane, and it wasn't a weather balloon, and it wasn't a satellite, then, well, it had to be a UFO. The entire definition was based on a negative, on what something wasn't. But that's all changing.
The whole approach has shifted. We've moved away from just random, anecdotal stories of flying saucers and toward a structured scientific discipline. Now, these phenomena are being defined by repeatable, consistent patterns, physical signatures that we can actually observe and measure. In other words, they're defined by what they are.
And that brings us to the most important term for this entire explainer: UAP Observables. Look, this isn't about belief. It's a framework for analysis. These are the specific characteristics that, when they show up together, tell analysts they're looking at something that operates completely outside of our known aerospace technology.
So, where did this checklist even come from? It really started with 5 key traits that were codified by Louis Elizondo, who used to run the Pentagon's UAP program, ATIP. These 5 became the litmus test for what they started calling impossible performance. So here they are: anti-gravity lift, sudden acceleration, hypersonic velocities without any signatures, low observability, and transmedium travel. Let's break down what each of these actually means. First up, anti-gravity lift. And this is probably the most fundamental one. We're talking about objects that can just hang there, totally silent, or move around without any visible means of propulsion. I mean, no wings, no roaring jet engines, no propellers, not even a puff of heat exhaust. They just seem to ignore the basic rules of aerodynamics as we know them.
Then you've got sudden and instantaneous acceleration. The classic example, of course, is the 2004 Nimitz encounter. You had objects reportedly dropping from 80,000 feet down to sea level in less than a second. The G-forces involved in a maneuver like that would be in the thousands. Any aircraft we could build would be turned into confetti, and a human pilot, forget about it.
And they hit these incredible speeds completely silently and invisibly. When one of our aircraft goes hypersonic, it creates a massive sonic boom and leaves a huge heat trail. UAPs have been tracked doing well over Mach 20 while staying completely cold and quiet. Now, what's really fascinating is that this suggests they aren't pushing through the atmosphere the way our craft do at all.
Number 4 is low observationability. You'll sometimes hear this called multispectral stealth. This is when a craft can be seen by one type of sensor but not another. So a pilot might see it plain as day with their own eyes, but the multi-million-dollar radar system is totally blind to it. Some reports even describe a kind of active camouflage, where the object looks blurry or almost transparent.
And finally, transmedium travel. This is the ability to move between totally different environments, like air and water, without any change in performance. The famous Tic Tac from the Nimitz case was apparently seen entering the ocean without so much as a splash. That kind of capability is it's far beyond anything we can currently do.
Okay, so those first 5, the original 5, they're all about what these objects do, their impossible performance. But now we're going to shift gears. The next 5 observables, the follow-on 5, try to get at how they might be doing it. They're like searching for the mechanical signatures behind the magic.
So let's get into this next set of 5. These have emerged from more recent scientific work, from researchers who are digging into the data and trying to find tantalizing clues about the actual physics at play here. Observable number 6 is gravitational lensing. Now, the idea here is actually pretty simple. If a craft is powerful enough to bend space-time in order to move, it should also bend the light that passes around it. So what would you see? You'd see background stars or clouds literally warp and distort as the object flies past. This is the first potential optical signature of a real-life gravity drive. Number 7 is just fascinating. It's called leading-edge vapor cones. So, you know how a jet creates a vapor trail behind it because it's pushing air out of the way? Well, some UAPs have been seen with a cone of vapor forming in front of them. The theory is that some kind of propulsion field is compressing space ahead of the craft, which causes the moisture in the air to condense. It's the exact opposite of what we expect.
All right, number 8 is something called oscillation blur. We all know what motion blur is, right? A fast object and a slow camera shutter give you a streak. But this is different. High-resolution video has shown a weird kind of blur, like an edge duplication or a flickering. The theory is that this isn't from the camera,
but from the propulsion field itself, cycling on and off at an incredibly high frequency.
Observable 9 ties right back into that anti-gravity idea. Researchers notice that disc-shaped craft are often seen tilting their belly or the bottom surface in the direction they're about to travel. Now think about that. That tilt-to-travel motion is exactly what you'd expect to see if the craft were creating a little gravity well just in front of it and then basically falling into it to move.
And number 10 is the saucer-like skipping motion. So many reports, from way back in the day to modern ones, describe these things moving like a stone skipping across water. This isn't just a weird movement. It could be a massive clue that the drive system is pulsed. It's not a constant push like a rocket, but a series of discrete, incredibly powerful bursts to move along its path.
Okay, so you take all 10 of these observables, you put them all together on the table, what do you get? What's the big picture? Well, you start to see a framework that points toward a fundamentally different understanding of physics and propulsion.
This table really just brings it all into sharp focus. A drone, a bird, they're limited by mechanics, by biology. They have to play by the rules of aerodynamics. But then you look at that UAP column, instantaneous acceleration, moving through air, water, space. You realize you're not just looking at a better airplane. You're looking at a completely different class of physics, a leap from aerodynamics to what's being called field propulsion.
And here's the bottom line. Our technology and everything in nature on Earth are basically slaves to the atmosphere. We have to push against a medium, like air or water, to move. But what these 10 observables strongly suggest is that UAPs don't push against a medium at all. They seem to interact directly with the fabric of space-time itself.
Which leads us to this final, really mind-bending concept, the inertia trap. How could anything possibly survive thousands of Gs of acceleration? The theory is that it doesn't have to. The craft, and anything inside it, might exist within its own localized warp bubble, where the local experience of inertia is zero. From inside that bubble, you'd feel absolutely nothing. You aren't moving through space, you're moving space around you.
And that leaves us with the one final, really provocative question. This 10-point checklist, it gives us an incredibly powerful diagnostic tool. It helps us separate the truly anomalous from the conventional. It tells us what to look for. But if these are the signatures, then what in the world is the technology behind them? That remains the ultimate question.